Hi there, this is Avthar. I'm a developer advocate at Timescale, and today I'm going to take you through the demo that we showed at AWS reInvent 2019 about using Timescale to store IoT sensor data. Now, there's two things that I'm going to take you through today. The first one is Timescale for IoT monitoring, so monitoring the state of your system at a certain point in time or the state of your devices. And the second one is Timescale for time series analysis of this IoT data. So let's get started. In this dashboard today, I'm going to show you the example of bus data from New York City. So we're going to track and look at the behavior of buses that are fitted with sensors in New York. This data comes from the MTA. I'm running it through an AWS Lambda function and putting that into Timescale as the data source for this Grafana dashboard that you see today. So in this example, what I'm showing is the location of buses in New York City live. And I'm color coding them by their routes. In this case, buses that are in Manhattan or originating in Manhattan are in blue. The ones from originating in this area, Queens, are in red, and the ones in this area, Brooklyn, are in purple. And you can see, buses actually are traveling between regions where you have some buses coming from Queens to Manhattan here, and buses from Manhattan to Queens. You can see this blue dot, traveling over here. So it allows you to see the movement of these buses from their different origins. And in this case, we're using location data, but you can also use things like, for your devices, any sort of metric such as temperature, humidity, pressure, anything that anything that's important to you. If you want to see that in a real-time dashboard, this is an example of how you can do something like that very easily with Timescale. And the query that produces this, because we're built on Postgres, it's a very simple SQL query. All I'm doing is taking the time, the vehicle, and the route ID, and then color coding based on what route the vehicle is taking. And then because we're dealing with geospatial data, such as location, I just have to deal with these geometry columns as well. Another thing that moving on from that point, another thing that Timescale allows you to do is to combine your time series data and your geospatial data. Because we're built on top of Postgres, we can use other extensions. In this case, I'm using PostGIS, which helps to deal with geospatial data, to enable you to do geospatial and time series analysis. So one example of this and a more complex monitoring query that you might want is to know all the buses that are off their specified route. So this is analogous to knowing, show me the anomalous devices that I have, or devices that have gone beyond a specific threshold, or devices that are in a certain danger zone. So in this case, we can see the buses that are off their route are in purple. The buses that are okay are in green. How we make this happen is actually by combining time series data. In this case, we want to know the buses at a certain point in time. We're also combining time series data with geospatial data with location. But lastly, because we need to know the notion of a route, which is a relational notion, we're combining this with relational data or metadata. And thanks to Timescale being built on top of Postgres, you no longer need a separate database to store your relational data or keep your time series and your relational data separate. You can actually do that in the same database and just use, as I'm doing in this case, a SQL join, where I'm joining this relational geofences table with the time series hyper table that holds my bus data. So that allows me to produce this visualization, which shows me, the anomalies that are going on in my devices. The last thing that I'm going to take you through today is the Timescale for time series analysis. So one thing that you might want to do is look at trends in your data from your devices. Timescale allows you to look at these trends in arbitrary time intervals. You're no longer confined to look at things by 1 second, 1 hour, 1 minute, or if you were to do it in just vanilla SQL, it'll take you 10 or 15 lines of code. We've condensed that down into one SQL function that allows you to look at things in arbitrary time intervals. So say I want to look at things in 45 minutes or maybe 4 hours. I can do that very easily and allow me to look at patterns, given the time intervals that I'm interested in. This is a one-line SQL function called time bucket. you'll use that a lot when you're doing analysis or dashboarding with Timescale. The other thing I want to chat about is dealing with gaps in your data. So everyone who works on IoT knows that gaps in your data are a fact of life, and you can't really escape them. So in this case, I'm going to show you dealing with these gaps. So what I'm going to do is look at data from the past 7 days. And here I can see at 3 a.m. I actually have a gap in my data yesterday. So the question is, how do we deal with this? Timescale gives you a one-line SQL function in order to deal with the gaps in your data. So, these gaps might occur because of devices going offline or network latency. Timescale, so let's look at 3 o'clock. The function that I'm using here is a timescale function called LOCF, which is last value carried forward. And in this case, I'm carrying the one bus that I saw at 2 a.m. over to 3 a.m. where I had my gap. So exploring the SQL, in this case, I'm bucketing by 1 hour and then specifying LOCF, how I want to take and deal with those gaps in data. We also realize that taking the last value forward might not be the best solution all the time. So we've also created another way to deal with, which is linear interpolation, where you actually take the last value, you actually take the average of the last the last known data points. In this case, for 3 o'clock, I'm actually taking the average of one bus and two buses that I saw at 2 and 4 o'clock respectively. In this case, 1.5 buses is not something realistic, but for a continuous variable, it might be more suitable. So that's Timescale for IoT monitoring and analysis. The best database to use to keep this kind of time series data. We encourage you to get started. Check out our documentation. It's super easy to install and to get started. We have a bunch of tutorials. You can actually recreate this specific tutorial. I'll link to the resources below. And you can also sign up for Timescale Cloud for the hosted and managed version so that you don't have to waste any time managing and installing. You can get started and get monitoring and analyzing very quickly.